We learned a lot by working on our inbox contract, but we only wrote a tiny bit of Solidity for it. In this video, we're going to kick off our next project, which is going to focus a lot more Solidity code, and we're going to get to see some of the more intermediate features of Solidity in general. In this section, we're going to talk about the purpose of the next contract we're going to make. So we'll talk about what its goal is, and then we'll do some initial design or architecting of the contract itself. So let's talk about what this contract is going to do. The next contract we're going to work on is going to be a lottery of sorts, or kind of like a raffle. We're going to create a contract that we're going to call lottery. It will have a prize pool and a list of people who have entered for the prize pool. So let's imagine that we have two players, player 1 and player 2 over here. These two players can send in some amount of money to our contract. As soon as someone sends money into the contract, they will then be recorded as a player in the game. So this players box right here has P1 and P2, which represent player 1 and player 2. The ether that they send into the contract will be held in a prize pool of sorts. At some point in time, after some number of people have entered the contract or entered the contest, a third person or a third party of sorts, who we will refer to as a manager, will tell the contract to pick a winner. When this manager tells the contract to pick a winner, and one thing I want to make clear about this is that it's not the manager who's picking the winner. The manager is telling the contract to pick a winner. At that point, the contract will look at its list of participants. It will pick one of these two players right here, and it will send all the money out of the prize pool to that particular winner. At that point, the lottery contract then resets, and it then becomes ready to accept a new list of players and repeat itself all over again. So essentially, it's a self-repeating contract that can be used for playing a tiny little lottery or raffle, whatever you want to call it. So it's going to be a fun little project because we're going to get a much better sense of how we can enforce some level of security around a contract. We'll figure out how to work with Ether from within a contract, and we'll figure out a lot more about some of the basic data structures of Solidity. Let's pause right here. We'll continue in the next video, and we'll start talking about some of the basic requirements of this contract. So I'll see you in the next video. In the last video, we went over the idea of a lottery contract. The idea behind this is that people can enter into it. At some point in time, a random winner is picked, and they get a big sum of money. Let's now continue by talking about some of the design considerations and maybe the internal API of the contract itself. Now, I've taken a little stab here on some of the different variables and functions that we might need. I'll tell you right now that there's going to be several other functions that we're going to write, but this is kind of an initial take, and we'll figure out what additional functions we need over time. So I think that at a very basic level, there's two different pieces of information that we want to store with the contract. Firstly, I think we should store a manager variable. This will be the address of the person who created the contract. So this is going to be the person who has the ability to, at some point in time, tell the contract to pick a winner. Only the manager should be able to tell the contract to pick a winner. No player should be able to initiate that process. So we're going to record the address of the person who created the contract simply so that we can verify that it's the manager at some point in time who is attempting to tell the contract to pick a winner. I think we should also store a list of all the different people who have entered into the lottery. We might call this something like players. This will be an array of addresses for every person who has sent money to the contract. As soon as someone sends money to the contract, that means they are automatically entered into it. As far as functions go, I think that there's two obvious ones that we'll probably need. Firstly, I think we'll probably need a function called something like enter. So this will be the function that someone can send a transaction to enter themselves into the drawing to win the prize pool. In order to call enter, we should make sure that someone is sending along some amount of ether. So remember, you enter into the contract by sending some money to the contract. So I think that enter is a pretty reasonable name for that function. The other function that we'll probably need is something like pick winner. So this is a function that should randomly pick a winner out of the list of people who have entered the contract, and then send them the entire contents of the prize pool. So I think at a very high level that encapsulates the basic behavior of our contract. Like I said, over time, we're going to realize that we probably need some additional pieces of functionality here, but this at least will give us some initial guidance on how we should approach the problem. So let's continue the next section. We're going to start to use Remix to draft out an early copy or an early draft of this contract. So see you in a minute. In the last video, we discussed some of the different variables that our contract is going to have. We had said that we would have a manager variable, and this would contain the address of the person who created the contract. If we think back to our last contract that we worked on, the inbox contract, you will recall that we had a variable in there called message. And you will also recall that every time we make a variable, we have to declare the type of the variable as well. In this case, the message variable was of type string. So I got a question for you now. Knowing that we need to store the address of a person who created this contract, what type of variable do you think manager should be? Well, I think maybe string would be a really good guess because we know that addresses are sequences of numbers and letters. So if you guessed string, hey, that's a totally reasonable guess. However, in the world of Solidity, there is another type that is available to us, the address type. An address type, or a variable of type address, is specifically meant for, yeah, you guessed it, storing addresses. Now, as soon as I say that there's an address type, you might immediately start thinking, well, what other types are there? So clearly we know that there is an string type and there is a address type, but what other types of variables can we create with Solidity? I think this is going to be a good point for me to introduce the idea of some other types that we have available in the language. Our lottery contract is not going to make use of many of these other types, but I just want to give you a quick introduction to some of the other types we have available, because we will use some of these other types in the future. All right, here's a table of some of the basic types that we have available to us in Solidity. Notice that I say basic on here. There are other types, but they are more complex. And these, for example, might be an array or a mapping. And we'll discuss those other more complex types in due time. So let's talk about some of these different basic types. You've already seen an example of a string. A string is, just like it is in other languages, a sequence of characters. And so an example might be the string hi there, or the word chocolate, like so. A Boolean is another type that you've probably seen in other languages as well. So Boolean value would be simply the values true or false. String and Boolean, I think no matter what language you have come from in the past, be it JavaScript, Ruby, Java, whatever it might be, I think these two right here are going to be pretty straightforward and clear. But if you're coming from Ruby or JavaScript, these next two might be a little bit more complex. So if you're watching this video, I am going to assume that you've got a background in JavaScript, and so I'm going to give you a little bit of a detailed description about these two types right here. These are of type int and uint. It's short for integer and unsigned integer. These are both intended to contain numbers. So numbers like, for example, 0, -30,000, or 59,000, whatever it might be. The big difference between an integer and an unsigned integer is the presence of a sign that indicates whether or not the number is positive or negative. So the term unsigned literally means this number does not have a positive or negative sign associated with it. So an unsigned int can only be positive or 0 or greater. Essentially, it can only be positive. I'm going to go into a little bit more detail on ints and uints, and this might sound like it's going overboard, but trust me, this is stuff that you will probably eventually have a question about. So when we start writing Solidity, you're going to see not only types of int and uint, but you will also start to see types where we have the word int and then a number right after it. So for example, you will see in a lot of Solidity code the word int8 or int16 or int32. The number after the word int specifies the number of bits that are used to store this particular number. The number of bits that are used to store a number will specify exactly how large a number this variable can contain. So if you see a type of int8, that number can only hold values anywhere from -128 up to 127. Int 16 can only hold from -32,000 to +32,000, and so on. We have sizes of int in multiples of 8. So we have int 8, 16, 32, 40, 48. You get the idea. It goes on all the way up to int 256. Int 256 is made for storing really, really, really large numbers, either really negative or really positive. The last thing I want you to be aware of around integers is that whenever you see the type int, that is an alias as int 256. So if you see some code that says that this is a variable of type int, that means that it is a variable of type int 256. They are the same thing. All these rules also apply to uints as well. So we can have a uint of 8, uint 16, uint 32, 40, 48, and so on. Remember that with the uint, we don't have negative numbers. So we take that same range of numbers, but the minimum now becomes 0. So whereas before we had -28 to 127 with an int 8, with a uint we can store values from 0 up to 255, and then 0 to 65,000, and 0 to 4 billion, and so on. Just like with ints, the term uint, or the type uint, is an alias for uint 256. At this point, if you're from the world of JavaScript and you haven't really worked with a strongly typed language before, where you have to specify the size of the number you want to work with, this might seem a little bit overwhelming. For example, when should I pick a uint 8 versus a uint 16? Well, to be honest, at the end of the day, if this really seems overwhelming and you don't want to worry about the size of your numbers, you can always just fall back to using a uint or an int everywhere. You do pay for the storage of these values, remember that. So the larger the type, the more you have to pay for storage. But at present, the increase in price is not extremely significant. So as you're just working with the language and getting used to Solidity, my opinion is that there are way better things to be concerned with. So unless you know what you're doing, unless you decide that you really want to hone in on the correct range of variable, I really encourage you to not sweat it too much just yet. When you get some more experience with Solidity, then you can start worrying about this very, very small detail. Again, there really are way better places to spend your time than worrying about the size of your variables. All right, just a couple more on here. The last thing I want you to keep in mind about int and uint is that they cannot store any decimals. So only whole numbers. Well, technically it's not a whole number, but you get the idea. No decimals. If we want to use a decimal, we have access to fixed and ufixed. Ufixed in this case, just like before, means unfixed. So unfixed means we cannot have a negative number, but they can both have decimals. Now in practice, these might seem like you're going to want to use fixed and unfixed much more frequently. But whenever we're working with decimal numbers, it usually means that we're doing some type of math calculation in our code, right? Like we're doing some division or subtraction, or excuse me, some division or multiplication of already fixed numbers or whatever it might be. In the world of contracts with Ethereum, we usually do not end up doing a lot of math inside of our contracts. Remember, these contracts are way more about storing raw data and implementing some simple, very simple business logic. As soon as we start doing complex math, remember, we pay for every operation that occurs inside of our contract. And so it just ever so happens that as we're writing these Ethereum contracts, we very rarely end up putting some really critical business logic or some really complex math, because we don't have to pay for doing that math. We'll see some pretty good examples demonstrating this as we go throughout the course. Now, the very last type on here is the one that I mentioned at the start of the video, the address type. We specifically use the address type for storing addresses because it is a type that has some methods tied to it for sending money. So if we create a variable of type address and then store an actual address on there, we can reference that variable and call some methods on it to send money to that address, which is exactly what we're probably going to have to do when we start working on our lottery contract. Because remember, at some point in time, we're going to want to send the winner some amount of money. All right, so this has been a pretty long lecture on some of the basic types that are available to us. Let's continue the next lecture, and we're going to start working on our code for our contract, and we're going to make a variable of type address. So I'll see you there. In the last video, we reviewed some of the different types that are available to us with Solidity. One of the more important types that we have access to is the address type. And so as soon as we start talking about storing the address of the person who created this contract, well, chances are we're going to want to make that variable of type address. So at this point, I think that we're ready to start working on the contract, and I think we'll get started by declaring some of these initial variables inside of it. To write this contract, we're going to be using the Remix editor again. Personally, I really like using Remix because it just makes it so easy to quickly iterate and test your contract. Eventually, we'll copy paste this contract over to our code editor again and write some tests around it with Mocha, just like we did previously. But for this first run through, we're going to use Remix to do some quick iteration. Remember that you can get access to Remix by going to remix.ethereum.org. Now, when you come here, you're probably going to see our code from the previous contract, the inbox contract, appear in the code window. We don't really need this contract anymore. We've already got a backup of it inside of our code editor from the last section. So I'm going to highlight the entire contract and delete it. Now do remember that we want to leave behind the pragma mark here so that we can specify the version of Solidity that we want to use. Now on line 3, we can declare our new contract by using the contract keyword. And then we'll specify the name of this contract, which is going to be lottery, like so. Now in the first line of the body of the contract function, we're going to start to define the different variables that we want to have access to. We're going to discuss the players variable in a little bit. So for right now, we're just going to focus on the manager variable. Remember the order of declarations that we use to make a new variable. We specify the type, its visibility, and then the variable name. So in this case, the type of variable we want to make is address. We want its visibility to be public, and the variable name will be manager. Now you might be kind of curious about public in this case. Remember, we have already discussed the visibility can be either public or private. Using public or private enforces no security whatsoever over the data inside of your contract. Using public or private is much more about making it clear to other developers whether or not they should be able to easily access this variable. In this case, I'm going to make manager public because we are going to eventually write a front-end JavaScript application around this lottery contract. And from that JavaScript application, I want to make sure that we can easily access the address of the person who created it. In other words, easily access the manager variable. Now the next thing we need to think about is exactly how we're going to set the value of manager. We want the manager variable to contain the address of whoever created this contract. So chances are we're going to want to set the value of this variable right here the instant someone creates an instance of lottery, or the instant someone deploys this contract. Remember that there is one function that gets automatically called whenever we create a new instance of a contract, and that is the constructor function. We can define a constructor by making a function that has the same exact name as the contract. So we'll say function lottery, we'll specify its visibility as public, and then we can put it in the function body. So inside of here, we can add some code to take the address of whoever just deployed this contract and assign that to the manager variable. When we worked on the inbox contract previously, we took in an argument to the constructor function. Remember, that was the initial message. So you might be thinking that we want to take in an argument of the address of the person who creates this thing. And that would imply that whoever creates this needs to provide their address as an argument to the contract. But that would be a little bit of a pain in the rear. Like in an ideal world, we should really just say, hey, I want to make a new lottery, click a button, and poof, here it is suddenly. So we need to figure out some more clever way, or a little bit more programmatic way, to obtain the address of the person who is creating this contract. Fortunately, there's a really easy way to do that. Let's take a quick pause. We'll come back to the next section and we'll talk about exactly how we can automatically find out the address of the person who is attempting to create an instance of our contract. So we'll take care of that in the next video. In the last video, we discussed how we need to somehow update this manager variable whenever someone makes a lottery contract. So inside this constructor function, we're going to somehow want to figure out who just tried to create this new contract and assign the address of their account to the manager variable. In order to do this, we're going to use a global variable that is included with any time that we invoke a function in a Solidity contract. So let's take a look at a diagram that's going to help us understand exactly what this global variable is. As a quick review, anytime that we want to invoke a function, or in this case, create a new instance of a contract, we have an account, we create a transaction, and we send it into the network. And that's what creates our contract instance. The global variable that we're going to be using is referred to as the message object, or MSG for short. This object has some properties on it that describe both who just sent in a transaction to the network, and it also describes some details about the transaction itself. Now, one thing I want to make clear here is that this MSG object is available not only when we create a new contract, it's also available with any function invocation. So if we were to say call a function, we still have access to this MSG object. Again, it is a global variable that is used to describe who just sent in a function invocation. Let's take a look at some of the properties that are included on this message object. All right, so here we go. We've got 4 different properties that are super relevant for us. The first property is the data property. This is present on any transaction. So remember, the data property includes, in the case of contract creation, the contract source code. And if we're trying to just invoke a function or send a transaction to a function, then this will contain some of the arguments that we're trying to send to that function. It also has a gas property, which is the amount of gas that we have available to us to run some bit of code. Now, you might be thinking, oh, this is great. We can figure out how much gas we have available to run some code. We can make sure that we can actually run our code with the amount of gas that is available. Well, in reality, we very rarely actually make use of this property right here. Usually we assume that with any function invocation, an appropriate amount of gas has been sent along with the transaction. The next property is what's really relevant for us. So this is the sender property. This is the address of the person or the account who just sent in a transaction or a call to the network. And then finally is the value property. If a transaction is being sent in with some amount of ether tied to it, then the value property contains the amount of ether that has been sent in. So this is really important if we say want to make sure that someone is sending in a certain amount of money to our contract. And we actually will be making use of this value property later on inside the lottery contract itself. Okay, so again, the property we really care about right now is this message.sender thing, because it tells us the address of the person who is starting up this function invocation. Now, the last thing I want to repeat just one more time, remember this message global variable is available both when we send a transaction in and when we do a call. So anytime a function runs inside of our contract, we will always have this MSG object available. All right, so back inside of our code over here, we want to make sure that anytime a new instance of lottery is created, we want to get the person's address and assign it to the manager variable right here. So we're going to say manager equals msg.sender, like so. So I've been saying global variable, global variable. Again, a global variable, just like many other languages, means we don't have to do any type of declaration for this. It is an object that is always available inside of our code, inside of our functions. So we don't have to do any declaration or anything like that. It's just magically made available to us. Okay, so this right here should ensure that whenever we create a contract, we get the sender's address assigned to it. We can do a quick little test inside of Remix just to make sure that's the case. So I'm going to flip on over to the Run tab. I'm going to make sure that I select JavaScript VM right here, because remember, we want to use our local test network that is running inside the browser right now, rather than using the Rinkeby network. Then down towards the bottom here, or well, halfway down the page for you, remember I'm really zoomed in at this point, I'll click the Create button. That will pop open a new instance down here. And if I click on the Manager button, that will retrieve the value that is assigned to the manager variable. So I'll click on that, and it gives me an address of CA35B. And so CA35B should match up with the address or the account that has been selected right here that is tied to the virtual network that is running in the browser. So sure enough, yeah, CA3 and presumably 35B, so on. Cool, so it looks like our address, or excuse me, our contract is now recording the address of the person who created the contract. Now just one more time, this is gonna be the third time I say this, but I just wanna make sure it's really, really clear. We have access to this MSG object not only in a constructor function, we have access to it in any function that runs inside of our contract. And the reason that I am repeating this over and over is that we are going to be referencing the message object right here several times throughout this contract in many different functions. Okay, so with that in mind, let's continue the next section and start working on our next function. Whenever someone creates an instance of our lottery contract now, we're going to take their address and assign it to the manager variable. So we'll always know who the owner of any given lottery contract is. That pretty much finishes up our first variable here, the manager variable. Now we can move on to our next variable, which is the players variable. And this is supposed to be an array of addresses for each person who has entered our lottery. Before we just go ahead and create this variable, it's really important that we get an idea of how arrays work with Solidity. We spoke a little bit ago about some of the different value types or basic types that are available to us in Solidity. We spoke about strings, booleans, and so on. You get all these right here. We're now going to have a very similar discussion about some of the different reference types that are available to us. So an array in Solidity is an example of a reference type. As we start talking about these reference types, we're going to do a quick little divergence, or we're going to put our lottery contract on hold for just a little bit. So we're definitely going to come back to this, but this idea of reference types is really important in Solidity. And it's also where there are a lot of gotchas and tiny little issues that come up. So I want to make sure that we have plenty of time to discuss all these reference types. All right, so let's dive into it. Here's a listing of all the different reference types that we have available in Solidity. A lot of these are really going to look quite familiar, especially if you have experience with JavaScript in the past. However, like I just said, there's a lot of tiny little gotchas around them, and those gotchas are what make them a little more challenging. So let's go through each of these one at a time. The first type that we have available as a reference type is a fixed array. A fixed array means that we have an array or a collection of different values, and that array can never change in length. If you're coming from the world of JavaScript, this might seem quite surprising, because in JavaScript, we can create an array and always resize it on the fly. So there's absolutely no issue in JavaScript with removing elements entirely or adding new ones, essentially changing the length of the array. That's totally a-okay in JavaScript. But for a fixed array in Solidity, no changing the length. It's always going to be a fixed length. Note that every single element that goes into an array in Solidity must always be of the same type. Over on the right-hand side, we can see two examples of fixed length arrays. Note that the little arrow that I put in here is not a Solidity operator or anything like that. I only mean to say that an example of an integer fixed length array of length 3 would be 1, 2, 3. So the 3 here represents the number of elements that can exist inside this array. And then you can see over here, yep, there's definitely 3 integers inside there. And then similar over here, we can have a Boolean type array that has at most or at least 2 elements inside of it, and maybe those are like true and false inside there. Very similar to fixed arrays, we have dynamic arrays. So as you might guess, these are arrays that can change in size. They can grow or shrink in length over time. Dynamic arrays are going to behave much more similarly to how you are used to using arrays if you're coming from the world of JavaScript. So we can add in elements, we can remove them, whatever we want to do. We can really hack these things up. Whenever we declare a dynamic array, we don't place a little number inside those square brackets. So the presence of a number indicates how many elements an array should have. If we put a number in there, that means this is the number of elements. If we leave it blank, that automatically means that we are creating a dynamic array that can grow or shrink in length. For our project, the lottery contract, chances are we're going to end up using a dynamic array because we want to allow as many people as we wish to enter into the lottery. if we had added in some arbitrary requirement of our lottery contract, if we had said that at most only 5 people can enter into it, then that would have been a good example of where we would use a fixed array. But for us, we want any number of people to be able to enter, so I think we're going to end up using a dynamic array. Now I want to speak a little bit more about arrays very quickly. So we're going to speak about mappings and structs in the next video, but first I want to show you some examples of using an array in action. So this is going to be an example that focuses around mostly dynamic arrays, because personally that's what I expect you're going to be making use of in your own projects. So I took the liberty of writing up a little code snippet here, and the goal of this code snippet is really just to give you an idea of how we work with arrays. For the most part, they're going to feel very familiar. So in this example right here, you can see that I created a contract called test. My test contract has a dynamic array of unsigned integers called myArray. Sorry, I know the scrolling is jumping around here. It's because I'm so zoomed in, but I want to make sure that it's easily legible. Now inside the constructor function for this contract, you'll see that my array has a method called push. Push behaves just the same way as it does in JavaScript, so we can push in new elements that cause the array to grow in length. So when we push in a value of 1 right here, that makes our array have length 1, and the first element contains a value of 1. If we push in 10, that means that the second element will have the value 10, and you get the idea for 30. Third element, and it has a value of 30. We can retrieve the length of an array by calling .length or referencing the .length property on it. Again, very much like JavaScript, it should feel quite familiar. And then if we want to, we can access individual elements within an array by using the very familiar square bracket notation. And just like JavaScript and many other languages, Solidity arrays are 0 indexed. So to get the first element out of an array, we use the square braces, or square brackets, whatever you want to call them, and we would pass in 0 or reference 0 right there. Now there's one very interesting thing about arrays in Solidity that I want to mention right now, and I'm going to mention this many times throughout the course because this is something that many people find quite surprising. I want you to recall that whenever we mark a variable up here as public, we automatically get a new function created for us that allows us to access this variable. Remember, we saw that in action back on the inbox contract. Because we marked our message variable as being public, we automatically got a function called message. Now, something very similar exists around arrays in Solidity. However, its behavior is slightly different than what you might expect. So I'm going to deploy this contract right here, and I want you to see what happens when we try to access my array. So I'm going to click create. That's going to create my contract. Here's my contract right here. If I want to, I can get the first element. So that retrieves 1 because I pushed in 1 inside the constructor right there. I can get the array length, which is of length 3. And now here is the automatically synthesized function to get or issue a call to the variable myArray. So whenever we have an array in Solidity, the function that gets generated does not return the entire array. That's the important thing. That's the part that's a little surprising. Instead, the function that is generated always is going to accept one argument, and that is the index of the element that we want to retrieve in the array. So back when we were working with message, or the inbox contract, when we wanted to get message, we just clicked the message button, and that gave us the entire contents of the message variable, like the entire string. But whenever we are working with an array, we have to ask for individual elements. So I can say, like, give me the element at index 0, and that will give me 1. I can ask for the element at index 1, and that will give me 10, because that's the second value I pushed in. And I can ask for the element at index 2, and that will give me 30, because that was the third value that I pushed in. So that's just something to be aware of. Now, if you want to, you can always write a function that will return the entire array, like everything inside of it in its entirety. And I can very quickly show you an example of that. By the way, I know I'm going through this stuff very quick, but this is just your first taste of arrays to give you a sense of how they are similar or different from arrays in other languages. We're going to be repeating all these same limitations and stuff over time, so don't worry if it feels like we're going too quickly. I just really want you right now to be aware that some things are similar and some things are different. Anyways, back to this, let me give you a quick example of retrieving an entire array. So we could say, get my array. This will be public and view, and I'm going to say that it returns a type of uint, and it's a dynamic array. So I'll say uint and place my square brackets like so. And then inside of here, I can simply say return my array. All right, now I'm going to redeploy my contract. If I can scroll down. I think that I already deleted the other one, so I'll just click create. Yeah, there we go. All right, so now I've got get my array function right here. And if I click it, I get back all three values, 1, 10, and 30. So we can kind of circumvent this restriction right here, or I shouldn't even call it a restriction, but we can kind of get around the fact that the generated getter returns only one value at a time by writing our own function. However, even with this, there are some little gotchas that are going to come up over time. If we were working with simple values like uints or booleans or whatnot, we can return the entire array. But if we are working with more complex values like an array of arrays or an array of structs, which is another value that we'll discuss, then we can't quite use this technique so much. But again, that's something that we'll come back to and discuss in due time. All right, so at this point, we've spoken about some of the basics around arrays. At this point, I really just want you to have an idea that arrays exist. They can be dynamic in length or fixed in length. And in general, they mostly work in the same way that JavaScript arrays do. So let's pause right here. We're going to come back in the next video, and we're going to discuss some of the other types that are available to us in Solidity. Let's continue on with our list of reference types. In this video, we're going to talk about mappings and structs. We're not going to use either of these data structures inside of this particular project, the lottery contract, but on our next project, we definitely will. So this is more of a sneak peek of some of the different types we have available. At this point, I really just want you to know that these exist. That's all. You don't need to know the specifics behind them or anything like that. I just want you to know that they exist. When we come back in that next project, we're going to go over mappings and structs in much greater detail. All right, so let's talk about mappings a little bit. A mapping is a collection of key value pairs. So if you're coming from the world of JavaScript, you can think of a mapping as being very similar to an object. If you're coming from Ruby, they're like hashes. If you're coming from Python, they're like dictionaries. The key thing to keep in mind about a mapping is that all of the keys have to be the same type, and all the values have to be the same type as well. Keys and values, like the set of keys and the set of values, those don't have to be the same type, just all the keys have to be the same type and all the values have to be the same type. We can designate mappings by using what you see over here on the right-hand side. So we say mapping, we then specify the type of key that we want to use, a little arrow, and then the type of value that we want to use. And here's an example of where we would have keys of type int and values of type bool. Mappings are most frequently used for storing collections of data. And the reason I mention that is that when we start talking about a struct, these two are going to seem quite similar in nature. So let's move on to structs, and then we'll discuss exactly how these two things are different. So a struct is a collection of key value pairs, very similar to a mapping, but the values of this one, the values of a struct, can have different types. So here's an example of a type definition of a struct. We say struct, the name of the struct type, and then we specify all of the different properties that the struct will have. So in this case, I made a car. It can have a string of make, a string of model, and an unsigned integer of the car's value. We most commonly use structs to represent a singular thing. So this is a great example right here. We are representing a singular car, and this car has many properties assigned to it. We could also use a struct to represent, say, a desk, a piece of furniture, a person, a house. We usually use them to represent a singular thing. So at this point, mappings probably look quite similar. The difference here is that we usually use a mapping to represent a collection of things. So we might store a collection of different cars inside of a mapping, or we might store a collection of different houses inside of a mapping. In other words, use a struct to represent a singular thing, use a mapping to represent many things. The project that we work on in the next section, which again is where we're going to start seeing maps and structs come up, are going to give you a very good example of exactly how mappings and structs are different. And they very quickly will feel very different, but I know from the definitions I'm giving right here, they seem quite similar. All right, so that's just a quick overview on mappings and structs. Again, I just wanted to give you a quick taste. Let's pause right here, and there's one quick, really big gotcha that I want to mention about these reference types. So let's take care of that in the next video. We just finished up a discussion on some of our basic reference types. Before we move on, I want to mention a quick gotcha around fixed arrays and dynamic arrays. Before I tell you exactly what this gotcha is, I want to do a quick vocabulary review. So here's our vocabulary review of some basic programming lingo. Here's a snippet of JavaScript code on the screen. Notice how we have an array with some number of arrays inside of it. We would refer to these as nested arrays, right? You could refer to this as a nested array. You could refer to the entire structure right here as a two-dimensional array. So again, I just want to do a quick vocabulary review because if you don't remember that terminology, what I'm about to tell you won't make a lot of sense. All right, now that we remember what a nested dynamic array is, or just what a nested array is, I want to show you a quick diagram that's going to explain part one of a two-part gotcha. Yes, this is a two-part gotcha. So here's part one. Part one is that in the Solidity world, in other words, with the Solidity programming language, there is no issue whatsoever with making a nested dynamic array. In other words, a data structure that looks exactly like this right here. So in the Solidity language, this is not a problem. We 100% can build a data structure like this. However, remember that we are not working with Solidity alone. Eventually, we want to pull data out of our contract into the JavaScript world so that we can show some data on the screen inside of a web browser or an app or whatever it might be. So the issue here is that we do not yet have the ability to pull a nested dynamic array from the Solidity world over to the JavaScript world. So in the JavaScript world, nope, we can't communicate with Solidity. We cannot receive a nested dynamic array. Now that might seem very surprising because as you and I very well know, in JavaScript, yep, we absolutely can print this out. This is not an issue. We have a nested array right here, not an issue. So to be clear, this is not a limitation of JavaScript. It's not a limitation of Solidity. It's a limitation of the bridge between the two languages. That's the limitation. The communication layer, the translation layer between the two, that is where this restriction is coming from. We cannot communicate nested dynamic arrays. Now that might not sound like a big issue. You might be thinking, Stephen, you know what? I'm okay with that. I don't often make arrays of numbers like this. Okay, I believe that. That's fair. However, I do want to mention part two of this gotcha. So remember, I said it was two parts. Here's part two. Before I tell you exactly what part two is, I want to do one other quick piece of review. So back over here, this is a chart of all of our basic types. We looked at this just a couple videos ago. You will recall that one of our basic types was a string. That was a sequence of characters, and we're probably very used to strings. They represent words, sentences, whatever. Unfortunately, strings inside of Solidity are represented as dynamic arrays. So even though it looks like to you and me, this is a string right here, Solidity stores this and works with it as though it were a dynamic array. So what happens when you put those two facts together? The fact that strings are strings are dynamic arrays, and the fact that we cannot transfer nested dynamic arrays over to the JavaScript world. When you put those two together, it means that we cannot transfer arrays of strings over to JavaScript. We have no problem whatsoever storing arrays of strings inside of Solidity, but we are not actually able to move an array of strings over to the JavaScript world. There are, of course, somewhat easy ways to get around this. However, I thought it would be really handy if I just mentioned this to you right now, because I find it rather likely that at some point in time you're going to want to make an array of strings. Right? I think that it's completely reasonable to expect to do something like const colors is red, green, blue, right? This looks like a simple thing right here. Well, unfortunately, we can't really design our contracts with this kind of data structure in mind just yet. Now, to prove this to you, I put together a tiny little contract inside of another Remix tab. So here's a contract called test. I have created an array of strings right here, and I called it my array. Inside of this constructor function, I pushed a new string into my array. And then finally, I created a getArray function that attempts to return the entire array. Now you'll notice that all the code right here looks to be, more or less okay. Maybe since we don't know that much about Solidity yet, maybe we can't really say that it's perfect, but certainly you'll notice that there doesn't appear to be any notification inside the code editor that says that we made a typo or anything like that. However, if I pull open the right-hand tab over here, you'll see a message that says specifically unimplemented feature error. Nested dynamic arrays are not implemented here. And so what this error message literally means is, okay, what you did is totally fine, but we being Remix, does not have the ability to work or receive with nested dynamic arrays yet. So it's not an issue with Solidity. It is not necessarily an issue with JavaScript. It is an issue with communication between the two. So that's our first really big gotcha, I think, around Solidity. Again, this might seem like a very surprising thing, but hey, this is all a work in progress. Hopefully at some point in time, this will be resolved. There are already efforts and issues raised to fix this. However, at this point in time, we just don't have support for it just yet. All right, so now that we got that big gotcha out of the way, let's continue in the next video, and we're going to start working on our next variable, which was somewhere around here. Where is it? Right here, our list of players. So quick break, and we'll take care of that in the next video. We've now got a reasonable idea of all the basic and reference types that are available to us with Solidity. We're now going to go back to our lottery contract and use this newfound knowledge to start to implement some portions of the contract. In this video in particular, we're going to initialize our players variable, and then we'll start working on our enter function. So let's flip back over to our code editor inside of Remix, and we're going to start off by initializing the players variable. So underneath our existing declaration, we're going to initialize players as an array of addresses. Initializing a variable is, initializing an array in particular is always going to use the same syntax. We write out the type that is going to exist inside of the array, and then we write our square brackets like so. This creates a dynamic array that can only contain addresses. So we cannot put numbers in here, we cannot put in strings. The only thing that can go in is an address. Remember that if we put a number in here, that would create a fixed size array that can only hold up to 10 elements. But in this case, we want to allow an unlimited number of people to enter our lottery. So we're going to specifically make a dynamic array. Now after this, we're going to again place either our public or private keyword. In this case, I'm going to mark it as public again, because I'm really a-okay with other people trying to see what or who has entered into our lottery. And then finally, we're going to place the name of this variable, which I'm going to make players, like so. Cool. So now the next thing we're going to do is to start work on our enter function. Remember, if someone calls this, they are probably going to want to be entering into the lottery. So if someone calls the enter function, we're going to want to take that person's address and add it to the players array right here. Let's first start off by creating the function. So we'll write out function, the name of it. We're going to mark this as public because of course we want to allow anyone to call this function. And then we'll open up the function body. Now, one thing I want to mention about our contract in general, remember that in order to enter into the lottery, we have said that you have to send in some amount of ether. So here's that original diagram we looked at. We had said that for player 1 and player 2 to enter into the lottery, they have to send in some amount of ether right here. So in other words, whenever someone calls our function enter, we're going to expect them to send along some amount of ether. Whenever we create a function that expects to receive Ether, we have to mark the function as payable. And you'll recall that we spoke about this payable term right here way long ago when we started talking about function types. So some of the different function types we have are public, private, view, constant, pure, and then the last one down here was payable. So we use that payable keyword whenever someone should be able to call that function and send along some amount of Ether. So now we should be able to call the payable function and send along some amount of money. Then once they send in money, we'll want to make sure that we add in that person's address to the players array right here. So to add a new entry into the array, we want to push a new record in. So we're going to say players.push, just like we would with JavaScript. And then recall that to get access to the address of the person who is sending a transaction to this function right here, we can make use of the MSG, or the message global variable. And again, we can reference the .sender property on it. So we'll say message.sender, like so. Okay, so this looks good. Let's pause right here and then start to test out this contract in the next video. In the last video, we finished up our enter function right here. Whenever someone calls the enter function, we take their address and we add it to this array of players. And remember, the players array is a list of addresses. I think we're now at a spot where we can test this contract out inside of the virtual network that's running inside of our browser. So on the Run tab up here, I'm going to find the environment dropdown here at the top right hand side, and I'm just going to make sure that it says JavaScript VM. Remember, this makes sure that it's going to use the network that's running inside of the browser. Then a little bit lower, I'm going to make sure lottery is selected, and I'll click the Create button. That creates a new instance, which we see appear down here. Now we can immediately double check to see that the manager was set correctly. We did this once in the past. You'll notice that I have address CA35, and if I go back up here to the account that I used to deploy that contract, yep, it's CA3, presumably 5 after that as well. Now the next thing we'll probably want to do is use the enter function. So this should add us to the players array. So I'm going to click on enter right here. You'll notice that nothing really appears to happen, except we definitely do get a little pop-up over here inside the console. If we want to, we can try to access the array of players by using the players button right here. Remember that by default, whenever we mark an array as public, that means that we can only access one element at a time. We don't get returned the entire array. If we look at the first element inside this thing, we should see our address appear. So the first element is going to be at index 0. So then I'll click the button, and sure enough, we see again CA35. Now I'd really like to test to make sure that we can enter on other accounts as well. So I'm going to go back up towards the top. I'm going to find the account section, and I'm going to change my active account to the next one down on list. Now I'll go back down to the bottom. I'll click enter again. And now we should be able to update players to index 1. And we should see the next hash, or the next address, which is 1472. And if I look back up here, yep, it's 147. So we're definitely now recording the correct address for everyone who is attempting to enter the lottery. However, our lottery definitely has a big problem right now. Remember, the lottery pool consists of all the money that the players send into it. So if player 1 and player 2 send in 0 Ether, then there's really no money to be won. And what's the point of the lottery then? So I think that we need to somehow enforce a rule that if you want to enter into the lottery, you have to send in some amount of money. Luckily, as you might guess, this is something that is rather easy to do with Solidity and Ethereum in general. So here's what we're going to do. Right inside of our enter function, we're going to add another function call. This is a global variable, very similar, or a global function, very similar to the MSG one that you see right here. The function that we're going to call is require. Require is used for validation. We can pass in some type of Boolean expression to this require function. If that Boolean expression returns to false, then the entire function is immediately exited and no changes are made to the contract. If the expression evaluates to true, then code inside the function continues to run as usual. So the require function is a great thing to use to make sure that some requirement has been satisfied before allowing the rest of the function to be executed. In this case, I think that we should probably make sure that if someone is attempting to enter the lottery, they should be sending along to this enter function right here, maybe some minimum amount of ether. So inside of the require statement right here, I'm going to add in message, because remember, MSG is how we get access to the transaction that is coming to this function. And then to get access to the amount of money that this person is sending, we can reference the value property on that. And recall that we spoke about this MSG property just a moment ago in this diagram right here. So we have already made access to the msg.sender property. Now we are using value as well. And this is the amount of ether in way specifically that was sent along. Now we definitely want to make sure that these people send along some minimum amount of money. So I'm going to check to make sure that at least 0.01, and I think probably 0.01 ether is a good place to start. Now remember, like I just said, this is going to be the amount of money in way right here. So rather than putting in 0.01, we might have to convert this to 0.01 in way. Well, here's our Ethereum ether converter right here. So if I enter 0.01 ether, then this is the amount of way that we want this person to enter. Now, of course, if I take this number right here with all these zeros and put it into my contract like this is not very legible, right? It's really tough for you and me to look at this number and have any reasonable sense of what the minimum amount of money is to enter into the contract. Fortunately, there's a little helper to allow us to not have to write out these large numbers whenever we are trying to specify some amount of money. So rather than writing out this big number, we can write out simply 0.01 space and then ether, like so. When we write out ether right there, then this number will get automatically converted into the appropriate amount of way. So by writing out this statement in total, we're going to ensure that whoever is trying to enter into our contest is sending along at least 0.01 ether. Now, of course, you and I could definitely make this like 1 ether or whatever we want, but hey, remember at some point we're going to be using our Rinkeby test account to test this thing, and we only have like 18 ether right now or so, so we don't really want to be spending 1 ether at a time. For testing purposes, it's a lot nicer to just be spending like 0.01 at a time. Okay, so this is looking pretty good. Let's now test this out by redeploying our contract. So over here, I'm going to find the existing lottery contract that we deployed. I'm going to delete it. I'm going to swap back to our CA account up here, and I'm going to create it again. All right. Now I'm going to open up my console over here, because if we attempt to call the enter function without paying in the correct amount of ether, at least 0.01 ether, I'm going to expect to see an error message. I'm going to want to see something that says, hey, someone tried to call this function, but they did not meet this minimum requirement. Now, we haven't spoken about sending along money to a function yet. If you scroll back up to the top on the right-hand side, you'll see this section that says value right here. So this is how we send along some amount of ether to a function call. So I'm going to specify 0.011, because notice how this is greater than 0.01, so we need to be greater than 0.01. And then I'm going to change it over to ether in the drop-down right here. Then I'll scroll back down to our deployed instance right here, and I'm going to click on enter. So this should have successfully entered me into the contract. If I look at the players array, specifically index 0, and then click on the button, yep, I definitely got entered in. So let's now see what happens if we attempt to enter into the lottery without sending in the correct amount of money. On the left-hand side, I'm going to clear the logout, and then back up here, I'm going to try entering on the other account. So I'm just going to select any other one. And then this time around, maybe I'll try to enter with 0.00001 ether. So I'm definitely not meeting this minimum requirement anymore. So now down at the bottom right-hand side, I'll try to enter again. And very quickly, you'll see a big error message appear right here. So the error message says, transact to lottery.enter occurred, VM error revert. The transaction has been reverted to the initial state. So clearly, this require statement did its job, and it made sure that if we did not meet this minimum requirement, that we would just get kicked right out of the function. Now here's another gotcha. There's a lot of gotchas around Solidity, and here's another one that I want to mention. As soon as you start using these require statements, you're going to see error messages that look like this down here. I want you to notice that we have no information inside this error message that seems to indicate that we did not pay in enough money. So when you start using require, if your require statement fails and you get kicked out, that failure does not clearly get communicated back to you. And this ends up being a little bit of a pain when you're doing development of your contracts, because you might eventually have your function calls failing, but there's no clear message to tell you why it just failed. Again, this is just something I want you to be aware of, because when you start developing your own contracts, you'll see this error message right here, and you're going to start saying, wait a minute, I thought that was working. Why is it not working anymore? And there's nothing that's going to really draw your attention to require right here. Okay, so in this video, we learned about the require statement right here. We're going to be using require quite a bit throughout the rest of this contract and the next one that we work on as well. So we'll get a lot of experience with it. Let's pause here and we'll continue in the next video. In the last video, I had mentioned that as soon as we start using require statements, we might see errors like this, and it gets a little bit challenging to figure out why our functions are failing, specifically because the error message does not say that we failed some require check. Now, fortunately, there is a good way inside of Remix in particular to make debugging of your function calls a little bit more clear. When we made this function call to the enter function, we saw in the console this little transaction log appear. And then next to it are two buttons. If you click the details button, you'll see some information about the transaction that was sent. And then right next to that, you'll see a debug button. So as you might guess, yes, this debug tool right here is what's going to make it a lot easier to figure out why our function calls fail. So we can click on debug, and then you'll see the right-hand panel change into something that looks like this right here. This is a fantastic tool that I really expect you are going to use quite a bit as you start writing your own contracts. This debugger allows you to step through the execution of your code expression by expression and get a better sense of how data is flowing around your contract. The big thing I want to draw your attention to is this slidey bar right here. The slidey bar allows us to fast forward or rewind along the execution of our contract. So if you drag it all the way back to the left-hand side, you start with the entire contract highlighted like so. You can then click this step in arrow right here, and it will start stepping you through the execution of the contract. So I can click step into. This makes it clear that, okay, we're about to run the enter function. So notice how this gets highlighted. Also notice how down here in these drop downs, you can get some information about the current state of our contract. So we can see the exact address of the manager variable, and we can also see that it looks like the players array has one entry inside of it right now. We can click the step into again, and then it starts to highlight each individual expression that is being evaluated by the Solidity compiler. Now in this case, of course, there's probably nothing wrong with 0.01 ether. It then looks at the value of message.value, and then it tries to compute the entire line altogether. And you'll notice that our little draggy right here is now at the very end, and we cannot step any further. So as you might guess, this right here was the end of our function call, and thus it makes it a lot more obvious to you, the developer, where the function call went wrong. So when you start seeing an error message like this down here, so something that just says, hey, error occurred, I really recommend you start to use this debugger right here, and it will give you a much better idea of not only where your function failed, but also what the values of some variables were as that function was running. On a very related note, besides the debugger, you might be curious if there is any type of console log functionality with Solidity. There is technically, but it's very limited in scope and a little bit more challenging to use. So if you are someone who is used to using console logs to develop and debug your code, well, unfortunately, that strategy doesn't work out quite so well when we start working with contracts. Instead, this debugger that you see right here is really the go-to solution, and this is really what I expect you are going to use personally as soon as you start working on your own contracts. Now, as time goes on, we're going to continue to use the debugger quite a bit, but in general, I'm going to kind of leave it to you to figure out how some of it works and how to interact with it. Because obviously, being in a course, I could introduce errors to our code and then say like, hey, let's use the debugger to fix this. but anytime I purposely put errors in the code, sometimes it gets a little bit misleading why things are breaking. Okay, so now that we've got a better idea of how this debugger works, let's pause here and continue working on our contract in the next video. Players now have the ability to enter into our lottery contract through the enter method right here. After the contract gets some number of players who have entered into the lottery, the manager of the contract should then be able to call the pick winner function. The goal of this function is to randomly pick a winner out of the list of players. And the key word in here is randomly. So we want to look at the list of players that are in the players array and randomly pick one entry in there and say, hey, congratulations, you're the winner, you get some amount of money. This function is going to be a little bit more challenging than you might think to write, and let me tell you why. If we were using any other language besides Solidity, so let's say JavaScript, Ruby, Java, whatever it might be, to pick a winner, we might say just randomly pick a number, and then using that number, pick a random element or a random index out of our players array right here. However, with Solidity, we do not get access to a random number generator. There's no such thing as a random number generator with Solidity. So instead, we're going to kind of fake the random aspect of this. Now, one thing I want to be really clear on, there is no random generator. So the kind of code that you and I are going to write to randomly pick a winner is what we refer to as a pseudo-random number generator. By pseudo-random, that means that it's really not quite random, and that our system for picking a winner can actually be theoretically gamed. In other words, people can kind of cheat on our lottery. So why are we making a lottery contract at all? Well, this is one of the big topics around Solidity. It is tough to do random number generators, and it turns out that a lot of contracts that people end up wanting to design sometimes require some aspect of randomness to them. So I just want to make it really clear in this contract that it is tough to truly randomly generate a number. All right, so let's talk about exactly how we are going to do it if it's supposedly so hard. So we're going to have a pseudo-random generator. Again, that means that it's somewhat possible for outside people to influence the outcome of our random generator. We're going to take the current block difficulty. Remember, we spoke about difficulty a little bit ago when we spoke about how it takes some amount of time to process an actual transaction. That amount of time that it takes to pick or kind of solve a block or close out a block is referred to as the block difficulty. This is represented as an integer. So this is, in theory, a large number. We're also going to take the current time and the list of addresses of all the people who have entered into our lottery. So I put on here addresses of entrants. Technically, let's change the vocabulary here. It's really the addresses of players. We're going to take these three inputs right here and feed them into the SHA-3 algorithm. Remember how this SHA-3 hashing algorithm works. It takes in some arbitrary data and then it spits out a really big number in hexadecimal. We're going to take this really big hexadecimal number right here and then use that to pick our random winner. So what I want to make sure, again, is really clear here is that the current block difficulty, the current time, and the addresses of players, to some degree, is known ahead of time. Whenever someone wants to pick a winner, we kind of know what the current time is. Like if you and I send a transaction in to pick a winner in our contract, you and I could, in theory, have a reasonable idea as to what the current time will be when this function is executed. We also know ahead of time the address of the players, and we probably also know the current block difficulty. So if we know these three sources of what we are calling randomness, then it's really not truly random at all. So again, there's really no good idea of random number generation with Solidity contracts. And if possible, you want to try to design your contracts to not include the idea of randomness at all. There are some workarounds to this. So there's kind of a workaround or two, and I'm going to link these workarounds in the next video as a text lecture. However, these kind of workarounds for getting some aspect of randomness into your contract is a little bit more difficult. So in this contract that you and I are putting together for the purposes of learning, we're going to take this approach. But if you have a contract where you really truly need to get some random number, then you can check out that article that I'll link in the next lecture. Okay, so let's start writing up this function. Now, rather than putting this function or this random number logic directly into the pick winner function, I think that it would be kind of handy to maybe make like a little helper function that we can call at any time that will generate a random number. So back inside of Remix, let's make a little helper function. I'm going to call this thing random because its goal is to generate a random number. We're going to make this a private function because this is a great example of where we are making a private function that I don't really want anyone else to call. I don't really want anyone else to write this or call this function. It's really just for you and me for the purposes of the lottery contract. Next, I'm going to mark this as a view type. We are not modifying any state or any data in the contract. The only goal of this function is to return a random number. And so we will also say that this function returns some value, which in this case is going to be an unsigned int. Remember that an unsigned int without any number after it is an alias for uint256. So technically when we put uint right here, it is technically a uint256. Just a quick reminder. Now inside of here, we're going to take those three pieces of pseudo-randomness. So we want our current block difficulty, the current time, and the addresses of our players. We're going to feed them into the SHA-3 algorithm. So first, we will reference the SHA-3 algorithm. So we can call the SHA-3 algorithm like so, by simply saying SHA-3, and then passing in the elements or the pieces of data that we want to have hashed. As a quick aside, I just want to mention that SHA-3 right here is a global variable or a global function. So we don't have to do any import statement, nothing like that. We can simply call SHA-3. You will also sometimes see, rather than a mention to SHA-3 right here, you might see kekgak256 like so. Recall that much earlier in the course, we mentioned that SHA-3 and this, however you pronounce this word right here, mean essentially the same thing. SHA-3 is the kekgak is a class of algorithm. SHA-3 is a particular instance of it. So kekgak256 and SHA-3 are the same thing. Then inside of here, we can start to pass in these sources of kind of pseudo-randomness that you and I want to make use of. So we can say block.difficulty. Notice that we are again making use of a global variable right here. So the block variable is a global variable that we have access to at any given time. Difficulty will be a number that indicates how challenging it is going to be to seal or solve the current block. Next, we will pass in, the current time, which again is a global variable of now. And then we'll also pass in the array of players, which we can reference simply as players. All right, now inside the random function, we do have to make sure that we return an unsigned int. But as we just discussed, this is our hashing algorithm and it returns a hash. So a hexadecimal number, but we're saying that we want to return an integer. So we can convert this hash right here to an integer by passing in the hash we just generated into a uint function like so. Uint. This will take this hash that we generate right here and turn it into an unsigned integer, which as we've discussed many times is essentially a number. And then the last thing we have to do is make sure we actually call it, or excuse me, return that value. So we'll say return and then the uint statement. All right, let's test this out and see how it's doing now. So back inside of my panel over here, I'm going to make sure that I have my JavaScript VM selected. I'm going to delete the existing contract that we've deployed for testing down here, and I'm going to create a new instance of the lottery contract. All right, so here's the new instance. Now the instant that we deploy this thing, you'll notice that we have no new button on here to actually call the random function. And that's because we marked this function as private. So whenever we mark a function as private, we get no ability to call that function directly. So just this one time for the purposes of testing, you and I are going to change private right here to public instead, just so we can run this thing and test it and make sure that we get some reasonably random number. So I'm going to change private to public as you see right here. I'll then kill the contract that we just created, and I will create a new instance by clicking create again. And now you'll see random appear. We can now click on random and you'll see that we get this gigantic randomly, or at least pseudo-randomly generated number. and we can click it, and every time we click it, it appears to be a new random number. But again, remember this is pseudo-random. It's not truly random because we can ahead of time have a reasonable idea of what a block's difficulty might be. We can have a reasonable idea of what the current time is, and of course we can very easily always retrieve a list of players. So although it looks like it is a random number, ahead of time people can kind of figure out these variables, and trust me, if that's all it takes to get access to some money that's stored inside your contract, you have to assume that people might try to game this right here. All right, let's change public back over to private, and we'll leave it right there. So let's pause right now, and when we come back to the next video, we'll start finishing up our pick winner function. So quick break, and I'll see you in just a minute. In the last section, we created the random function, but it might not be entirely clear exactly why we created it. You'll recall that the random function is going to return a random number that is probably going to be very, very large. That number is also going to be pseudo-random, so it's not truly random, and it's something that can be kind of predicted ahead of time. And so we're using this solely in a contract for development purposes. We're not going to actually deploy or use this in a very serious fashion, just because this function right here really can't be trusted. So now that we've got the random number generator right here, we can use it to randomly pick a winner out of our players array. So how are we going to use a really large number right here to randomly pick a player? Well, let's take a look at a diagram that's going to explain that process. All right, so right here is the line of code that you and I are going to write. So we're going to break this down step by step. The first thing we're going to do for this line of code right here to select a winner is to call the random function that you and I just created. Notice that to reference a function that is defined inside of our contract, we don't have to put this in front of it. We can just say random from another function, and that will automatically call it. So this is going to return to us a very large number. We can then use the modulo operator. The modulo operator works in the exact same way that it does in JavaScript. So it essentially returns the remainder of division between two numbers. And as a very quick example, let's take a look at our console. So over here, if I do say 10 modulo 3, well, 3 goes into 10 evenly 3 times. So 3 times 3 is 9. That leaves 1. So we would have a remainder of 1. So if we run this right here, there's our remainder. So as you will recall, the modulo operator returns to us the remainder of division. We can do very similarly 10 modulo, say, 4. So 4 can go into 10 2 times, and then there's a remainder of 2. So we get 2 like so. We can use this property to get us an index of the winner inside of our players array. So we will say random modulo and then players.length. So this is the number of players who have entered into our lottery. And that will return to us the remainder of division between random and the players.length. This number is always going to be between 0 and 1 minus players.length. So we can use that number as the index of the winner inside of our players array. That's a little bit confusing. So let's just take a quick look at exactly how this would work inside the console one more time. Let's assume that we've got, say, an array of 3 players, and maybe their addresses are, actually rather than using that, let's just put in names. So how about Bob, Alex, and Jim, like so. Now if we take a really large number and do modulo players.length, in this case it'll give us 1. And so in this case we could say that Alex is the winner because inside of our players array, Alex is at index 1. If we use a completely different really large number, we now get, say, 2. So in this case we would say Jim is the winner because he's at index 2. And then if we do one more time, okay, well 2, you get the idea though. Eventually if we changed it to another number, eventually Bob would come up as index 0. So that's how we're going to use this really large random number generator to somehow select a winner. Now that that is a little bit more clear, let's start working on our pick winner function inside of the Remix tool. All right, so over here, I'm going to add on a new function called pick winner. I'm going to mark this function as public, like so. And then inside of here, let's first create a local variable just for a second to store the index of the winner inside of our players array. So maybe we will create a new uint called index, and that's going to be the index of the person who is going to win. So we'll say random modulo and then players.length. So now if we have 3 players, index will be either 0, 1, or 2. Again, do keep in mind that the random function right here is pseudo-random. We don't actually know, or we kind of already know ahead of time what its value might be if we tried really, really hard. Okay, so now that we've got this index, let's take a pause right here. And in the next video, we'll talk about how we can use this index to send the winner some money. So we'll pick up in the next video. Now that we have the index of the player who just won, we can select them out of our players array and then send them some amount of money from our contract. So inside of the pick winner function, right underneath index, we can access the address of the person who just won by writing players at index, like so. This is a reference to our players array, which we had defined as a variable at the top of this contract. And then we can access a particular index inside that array by using the square bracket notation right here, just like as we usually would with JavaScript. So nothing new in that regard. Recall that we are storing a list of addresses inside the players array. So when we say players at index, that's going to return to us an address. Addresses inside of Solidity are not just like numbers or text hash values. They are actually objects of a sort that have some different properties tied to them. So this right here, players.index, just to be really clear, would be something like, 0x, blah, 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 A, B, C, D, blah, blah, blah. On this hash, we can call a collection of different methods to somehow work with this address. In this case, we can send some money to this address by calling .transfer. So that's a function that is available on every address that we store inside of Solidity. So again, it's not like a plain number, it's not like a string, even though addresses look like one, they have some number of methods tied to them. The transfer function will attempt to take some amount of money from the current contract and send it to this given address right here. So for example, if I said .transfer 1, that would attempt to transfer 1 way over to this particular address. But in this case, you and I don't want to send just 1 way, we want to send all of the way, all the ether that is contained inside the current contract. To reference the amount of ether that exists inside the current contract, we can say simply this.balance. This is a reference to the instance of the current contract, and then balance is the amount of money that the current contract has available to it. So this is going to take all of our money from the current contract, all the money that has been entered into this lottery, and then send it to this particular address right here. Now I think that we're just about at an area where we can start to test this out inside of Remix. There's one thing I want to be very clear on. This is not the last line of code that you and I are going to write right here. So you and I are going to write some other code inside this contract. But before we move on, I just want to test out this pick winner function and make sure that it's at least somewhat behaving in the way that we expect. So I'm going to pull up the sidebar over here. I'm going to make sure I delete any existing instances of lottery. I'm going to make sure that I have selected the JavaScript virtual machine. So this is the network that is running inside the browser. And then I'll create a new instance of the lottery contract. And here it is. Now the first thing we have to do is remember to enter the lottery. So you and I have to make sure that we specify some amount of ether up here towards the top as the value. So I'm going to say, how about we'll enter with 1 ether. We'll make it simple. And then I can click enter. Now, of course, we don't see a lot happen. If you see over on the console down to the bottom right-hand side, you should see a new transaction appear. If we put in a 0 for players, we'll see our address appear right here. So here's 1472, and that matches up with my current account that I have selected. So now I should be able to attempt to call the pick winner function, which should randomly pick a number, select some given index, and send that player all the money. In this case, we only have one person, which is us, you and me, inside of this player's array. index is going to work even if there is only one entry inside of there. So when we call pick winner, that's going to instantly send us back the 1 ether that we had deposited. Now, to just be really sure, at our account total up here right now, you'll notice that we have 98.99 ether. So when we click pick winner, we should see this amount right here go back up to roughly 99 ether. All right, so let's give it a shot. I'm going to click on pick winner down here. You'll notice that we get the transaction appearing on the bottom left-hand side. And then it appears that, yep, our account has gone up to 99 ether, which means that the pick winner function is definitely working the way we expect. Okay, so that definitely is a good little bit of progress. But like I said, this is not the last line of code that you and I are going to write. We still have to do a pretty good amount of work on this contract. So let's continue in the next section, and I'm going to point out a couple of things that are a little bit awkward about our lottery contract right now. So some things that we still need to work on. So quick break, and I'll see you in just a minute. In the last video, we successfully tested out the pick winner function. Now our contract still needs a little bit of work. In this video, I want to talk to you about one of the big issues around our current contract. At present, after picking a winner, we send someone some amount of money, and then that's pretty much it. We do absolutely nothing else. In an ideal world, we might try to reset our contract so we could run another round of the lottery immediately after picking a winner. In other words, it'd be really nice if we could just have an infinite series of lotteries just running again and again and again without you and me having to redeploy our contract. In order to do so, let's take a look at a diagram that's going to help us understand how to approach this problem. So we're going to start off over here at the left-hand side, where we first deploy a clean copy of our contract. When our contract is first created, we have an empty players array. In other words, no addresses inside of it whatsoever. We can then imagine that 1 or 2 people might enter the contract or enter the lottery, and we add their addresses to the players array. Now, here's the interesting part. When we pick a winner, if we empty out our list of addresses, we can then essentially reset the state of our contract back to how it was first deployed. So by emptying out the list of players, we can reset the state of our contract and automatically get it ready for another round without you and me having to redeploy the contract. So what we really want to do is just empty out the players array. That's pretty much it. By doing so, we can then infinitely run the contract without ever having to redeploy it. So let's give this a shot. Back inside of Remix, I'll find my pick winner function. Immediately after sending the winner some amount of money right here, we can then reset the players array by writing out players equals new address. We'll put down a set of square brackets like so, then a set of parentheses, and inside that we'll add 0. This right here creates a brand new dynamic array of type address. We know that it is a dynamic array because we put on the square braces right here without any numbers inside of it. Remember, we have both dynamic arrays and fixed arrays in Solidity. If we had put a number inside of here, that would have created a fixed size array, which you and I definitely don't want. We want a dynamic array in this case. Now you might be curious about the second set of parentheses right here. This says that we want to create a new array of type address. We want it to be dynamic, and we want it to have an initial size of 0. If we had put some number in here instead of 0, like let's say 5, then it would have still created a dynamic array, but it would have been initialized with a length of 5. So in other words, the players array would automatically turn into something like 0x000, 0x000, and you can repeat 5 times. Now, where are these 0x000s coming from? Well, remember, it's an array of type address. So every value inside of here must be of type address. If we attempt to create a length of 5 without having any actual values inside there, the values will be defaulted to 0. And a 0 address is what you see right here, essentially 0x and then a bunch of zeros after it. Now, we definitely don't want this to happen. We definitely want to start off with an empty array, which is why we are going to use 0 right here. So that is going to give us an array with absolutely no elements initialized inside of it, nothing. Cool, so that's definitely going to work out for us. Now after we pick a winner, we empty out that list of players, and we can then automatically start up another round of the lottery. All right, let's take a pause right here. When we come back in the next video, we'll talk about some other issues that currently exist inside of our contract. The next issue that I want to point out with our contract is the fact that anyone can call our pick-winner function right now. If you recall, when we first started talking about the layout of our contract, we had said that only the manager was supposed to be able to tell the contract to pick a winner. Nobody else should be able to. There's a couple of good reasons for this. First off, maybe the manager wants to be the person in control of the contract, and maybe they want to publish a date and say, okay, on January 30th or whatever day, a winner will be picked. And so we want to make sure that only this manager is able to pick a winner or to call the function to pick a winner. In addition, you'll recall that our random function is currently pseudo-random in nature. In other words, our random picker right here is really not quite so random. So if some stranger realized that if they called pick winner at just the right time, that would influence the values of these three elements right here, they could potentially make sure that a given player won. And we definitely don't want that as well. So in short, we want to make sure that only the manager is able to call the pick winner function. To do so, we can use a require statement just like we wrote before. So back up inside of our enter function, you'll recall that we called require, and we used require to do a little bit of early validation. If require is passed in a falsy value, then the function will automatically exit. So we can do the same exact thing inside of pick winner as well. But this time around, we'll make sure that the person who is calling pick winner has been marked as the manager of the contract. All right, so let's give this a shot. At the top of pick winner, we'll call require, and then inside of here, we need to place some Boolean logic to validate and make sure that whoever is attempting to access this function is in fact the manager. You'll recall that a little bit ago, we made use of the message global variable, and it had a property called sender, and that was the address of whoever was attempting to call the function. So we can reference message.sender, and we'll check to see if this is exactly equal to our manager variable. So I'll say equals equals manager, like so. With this line of code, we should be able to enforce that nobody can call pick winner except for the person who originally created the contract. In other words, the manager. Let's do a quick test and just verify that this is working the way we expect. I'm going to open up the Run tab over here. I'm going to click on the Create button. And then I'll enter the contest, first off, with the Enter button. Don't forget that you need to specify some starting value of Ether up here. So I will send in a value of 1 Ether. I will then enter the contract. If I enter in a 0 to players, I should see an address appear, and it looks like I do. And now, if I click on pick winner, it will call that function. But remember, I just deployed the contract. So at present, if I click on pick winner, it should successfully run this line or run this entire function right here. However, if I go back up to the top and change my account over to any other account on here, like let's say the last one, now if I try to call pick winner, it should fail entirely. I'm going to open up the transaction log down here on the bottom left-hand side, clear it out, and now when I click on pick winner, I should see an error message. So I'll click on pick winner, and sure enough, you'll notice transact blah blah blah, VM error revert. And you'll recall from a couple of videos ago, whenever we see this type of error message right here, it usually means not that something went wrong with trying to send a transaction to the function, it means that something went wrong while we were running the function. So if we wanted to, we could click on the debug button right here. That enters us into the debug phase. And if I go back to the start and then start clicking step through, we first check to see what the value of manager is. We check to see what the value of message.sender is. We check to see if those are equal and feed that into the require statement. And sure enough, you'll notice that's the last step that we go through inside of here. So no other code after this require statement is executed. Okay, so that definitely works out pretty well. You'll recall that at this point, we've mentioned many times the differences between public and private. So we don't use public or private to try to keep people from or to somehow enforce any level of security. Instead, to enforce security, we use require statements like the one that you see right here. All right, so let's pause right here, and I want to point out one or two little changes that we can still make to our contract in the next video. In the last section, you and I put together another require statement that required that whoever called the pick-winner function was also the person who had originally created the contract. This require statement definitely works perfectly where it is right now. However, I want to show you another little feature of the Solidity language that's going to become very useful as soon as we start writing some more complicated contracts. I want you to imagine for a second that we added in another function. So we're not going to do this. I just want you to imagine this for a moment. Imagine that we added in a function called something like return entries or something like that. And the purpose of this function right here was to loop through all the money that we had been sent inside the contract and send it back to whoever had sent it in. So maybe we would make use of this function if we wanted to cancel an entire round of the lottery and send back all of our money to whoever had sent it in. Let's kind of think through that function for just a second. Chances are we would not want to allow anyone to call that function. That's probably kind of an administrative level function, and we would probably want to make sure that only our manager was able to call it, right? Well, hey, that's no problem. We now have this require statement that we can easily copy paste down here like so. And by doing so, we are now able to say, yep, only the manager can call return entries. However, you'll notice that we now have some duplicated logic here. It's the exact same line of code duplicated in both functions. And this is a classic case of don't repeat yourself. In order to keep from not repeating ourselves, or how do we phrase that? To make sure that we don't repeat ourselves, we're going to use a feature of Solidity called function modifiers. So let's write out a function modifier, and then we'll talk about exactly what it does. I'm going to first start off by deleting this imaginary function down here, and then I'm going to replace it with a new function modifier. We're going to write out modifier. We'll then write out the name of the modifier, which in this case we'll make restricted. We'll place down a set of parentheses and then curly braces like so. Then inside of here, we'll write out that line of logic that we had just duplicated between our two functions. So it's going to be require message.sender equals manager, like so. So that's the duplicated line of code. And then immediately after that, we'll place underscore and then semicolon. Okay, one last little change, and then we'll talk about what this modifier thing does. I'm going to find my pick winner function right here, and immediately after the public keyword, I'm going to add on restricted, like so. Okay, so let's wait a minute. One last change. We're going to delete require right here. There we go. Okay, so now let's talk about exactly what this function modifier does. When we use the modifier keyword, we are defining a new function modifier to be added to our contract. Function modifiers are used solely as a means of reducing the amount of code that you and I have to write. We just created a modifier called restricted. The name of this modifier is absolutely anything that we want it to be. I called it restricted. You could have just as easily called it something like only manager can call. So whatever you want to call it, go for it. But in this case, I decided that restricted made a little bit of sense. Inside this modifier, we place one or more lines of code. And then after that, we place an underscore and a semicolon. Now here's where things start to get interesting. This has defined a modifier called restricted. If we add this restricted name to any of our other functions inside of our contract, you can then imagine that behind the scenes, the Solidity compiler is going to take all the code out of your function, so all this code right here, and add it to the modifier in place of that underscore. So the underscore you can kind of imagine as being like a little target, like take out all the code out of that function and stick it in where that underscore is. And so our pick winner function would eventually end up looking like this internally. So notice how we are still making that require call, and then we execute all the code for our particular function. This allows us to write one modifier and then use it in many places. So it's a classic solution to the don't repeat yourself problem. We only have to write the modifier one time. We only have to write this line of code right here one time. But now I can go back through to any line of code or any function, any function inside my contract and add on the restricted keyword. So if I add on restricted and so on, that would make sure that for any of these other functions, we are going to first run the require statement right here, and then the underscore means run all the rest of the code inside that function. Now, of course, you and I probably don't want to restrict the ability to enter the contract, so I'm going to take restricted off of here, and I'm also going to take restricted off of random as well. In this case, we really only want to restrict access to the pick winner function, so we're only going to use this modifier here. However, again, you can very easily imagine if we had other functions where we wanted to do this early validation logic, then we could use the restricted keyword that we have now created on those other functions as well. In practice, we end up using modifiers maybe once or twice, or hey, however many times is required for all of our different contracts. Anytime you start to see some repetitive logic, you can start thinking about using a modifier. Okay, so now that we have a better idea of how modifiers work, there's one last kind of big issue that I want to discuss about our contract. So let's move on to that big issue in the next video. I think our contract needs just one last thing. I think that it needs the ability to return a list of all the different players who have entered into the lottery. At present, we have marked the players array as being public. You'll recall that whenever we do that to an array, it gives us the ability to fetch just one person or one entry out of that array at a time. We probably don't want to have to call our address or our contract multiple times to get a list of all the different players who have entered. So instead, we are going to create one function that is going to return all of the different players who have entered. That will make it a lot easier to write some type of web application that can very easily tell us exactly who has entered and how many people have entered. And we can get that information with just one function call. So let's add in a new function at the bottom of our contract. I'm going to scroll down to the bottom. I'm going to add in the function. We're going to make sure that we mark this thing with the name of getPlayers. I think that's a reasonable name. I'm going to mark it as being public. I'm going to mark it as being view as well. So it's going to be public because, of course, we want everyone to be able to call this function. We don't want to restrict its access in any way. We also use the view keyword here because this function will not attempt to change any of the data stored in the contract. Whenever someone calls this function, they're going to expect to get back a list of addresses. So we will also mark this function with the returns keyword, and we're going to say that it should be returning a dynamic array of addresses. So we'll say address and then the square braces like so. Now, a little typo that's very easy to make. Remember that address has two D's inside of it. So it's not address with one D, it has two. All right, then inside the function body, we can simply return players like so. And that's pretty much it. All right, let's do a pause right here. We're going to come back in the next video and we'll do one last run through our contract, and then we'll start to pivot over to using this contract inside of a real web application. So quick review in the next video. Our contract is in a pretty good spot. The last thing I want to do is one quick run through and just make sure that everything is behaving the way we expect. Inside the right-hand nav over here, I'm going to make sure I delete any existing instances of the lottery contract that I have. I'll then again make sure that I have JavaScript VM selected. I'll make sure that I have the top account selected. And then I will attempt to create a new instance of the contract by clicking on the create button. And there we go. There's my new instance. Let's first try to enter the contract using two different accounts. So using the same account that I had just created, I'm going to add a value of 1 Ether, and then I will click on enter down here at the bottom. So that will enter me into the contract. And if I check my log, I should see something that essentially says, yep, transaction went through. Now I'll go back up to the top. I'm going to select a different account. I'm going to again set a value of 1 Ether. I'll scroll down to the bottom again, and I will click on the enter button again. All right, so we should now have 2 players entered into our lottery. If I click on the Get Players button, I should see a printout of the addresses of the 2 accounts that I just used to enter. If I click on Manager, I should see the original account that I used to deploy the contract. Let's now try picking a winner inside of our contract while we are logged in or kind of assigned as a different account. So I'm going to make sure that I am not assigned to the account that I originally used to deploy the contract. So for me, using the second account is just fine. Now if I scroll back down and click on Pick Winner, again, you'll notice that I have the error message down here because I am not the manager of the contract. So I should be able to go back up to the top, change the account back to the original one, go back down to the bottom, and click on Pick Winner again. And now I should see a successful transaction go through. If I click on Get Players, I should get back an empty array right here because our players array has been reset. And if I go back up to the very top, I should see that one of my 2 accounts should now have somewhere around 100.99 Ether because one of these 2 accounts just won 2 Ether. Okay, so this is looking pretty good. I'm pretty happy with how the contract turns out. Let's now take a pause. We're going to move on to the next section where we're going to start to take this contract and work it into a real web application. That's going to be a lot of fun, so let's get started on that in the next video. Our lottery contract is now in a really good spot. It's fully developed. Just like before with the last contract that we worked on, I do want to write out some tests for this thing using Mocha again. So just like we did previously, we're going to create a new project. We're going to put our contract into it, and then we're going to start writing some tests. To save some time, I think that we'll probably duplicate all the project files that we already put together for the inbox contract rather than writing all that stuff out again. So really at the end of the day, all we have to do is write a new set of tests. Testing might sound a little bit boring, but honestly, it will give you a much better idea of how we work with these contracts. So let's get to it. The first thing we need to do is to duplicate our project directory. At my terminal, I'm going to open up my working directory. Here's my inbox contract right here. I'm going to make a complete copy of this thing. So I'm just going to click duplicate. And of course, if you're on Windows, you can do a copy and a paste. When I duplicate, there will be a lot of project files inside of here, specifically all the different dependencies, so it might take a couple of seconds to get through. Once it's all complete, I am going to rename this folder. And just 1 second, there we go. Okay, so I'm going to rename the folder. Let's call this one Lottery, like so. Then inside of my terminal, I'm going to start up my code editor based on that directory. All right, and unfortunately my code editor usually takes up a moment to boot up as well, but here we go. Okay, great. So just like we had before, we've got our contracts directory. Right now it's got only the inbox Solidity file. We're going to replace this in just a second. Notice that we still have our compile, the deploy, and the package.json files inside of here as well. So essentially we're just going to co-opt this entire existing project and replace it with our lottery contract instead. So let's get started. Inside the contracts directory, I'm going to delete the inbox.sol file, and I will replace it with a new lottery.sol file. Then inside of here, I'm going to paste all the source code from the contract that we just put together inside of the Remix editor. So back inside of Remix, I'm going to copy the entire contract. I'll flip back over to the lottery file and paste it. All right, so I should see my entire lottery contract inside of here. Now I'll save this thing, and then we'll be sure to replace our test file as well. So I'm going to delete the entire test file, and then I'll create a new test file, and we'll call this one lottery.test.js. Great. All right, let's pause right here. We'll continue the next video, and we'll start working on some of our tests for the lottery file. In the last video, we created our new lottery project directory. We're going to go through the same process as we did before with our deploy script, our compile script, and our tests. We brought over the same compile and deploy.js files. However, both of those were hard-coded to look at the inbox contract inside the contracts directory. So we need to make sure that we update both of these to instead refer to the new lottery contract that we are working with. We'll first start off inside the compile.js file. Inside of here, I'm going to rename the inbox.sol file to instead be lottery. Then I will also make sure that after we compile our contract, we look at the lottery contract instead. So we should have :lottery, like so. As one last little change, we should probably update the name of this path variable as well from inbox path over to lottery path. So we'll change it to lottery path and lottery path, like so. I think that's it for the compile.js file. Let's check out the deploy.js file now. So here is deploy.js. Inside of here, it looks like I don't think we have any other statements regarding our inbox contract. However, if we look at the deploy script right here, and here's the deploy function call, you will remember that our inbox contract had a constructor function that took some initial argument to it, and that was the initial message. However, our lottery contract does not have any arguments that are passed to the constructor function. So in this case, we don't want to provide any initial arguments. So I'm going to find the comma arguments right here and delete it like so. Everything else in here should be good to go. So let's go ahead and save this file. Cool. All right, so just two small changes. Let's now pause again, continue in the next video where we will start working on the test file. So I'll see you in just a minute. Our project is now fully set up and we can start working on our lottery test file. I'm going to open up the test file. Now we did delete all the boilerplate code that we had in here before, so we will end up rewriting a little bit of code around the before each statement and some of the require statements at the top. However, this is really a good opportunity for us to review some of the different things that we did with our testing setup. So let's get started. At the very top, we'll first start off by requiring in the assert library. You'll recall that this is a helper library that is a part of the Node standard library. So we did not have to install any assert module or anything like that. On the next line, we will require in Ganache from Ganache CLI. Ganache is going to be our local test network that only gets created when we start running our tests. By just requiring it into this file, it automatically boots up the local test network. So we don't have to do any other special setup for it. Then we can require in Web3. Remember that when we first require Web3, we are requiring in the constructor function. So we use the capital W here. Then after that, we can set up our instance of Web3 with new Web3 Ganache.provider. Don't forget that the provider is essentially a replaceable little block that we stick into the Web3 library. The provider is what allows us to connect to any given network. So whenever we are using Web3 with Ganache, we pass in the Ganache provider. As soon as we start to move over to the browser, or as soon as we start to deploy our contract to a test network, we will replace this provider with whatever provider is appropriate. And we've seen some examples of that already. Next, we can require in our interface, which is the ABI of our contract, and the bytecode, which is the raw compiled contract from our compile file. So we'll say const interface and bytecode is going to come from ... compile, like so. Remember that we are using the curly braces here because we are requiring in an object that has the interface and bytecode properties. Next, we're going to declare two local variables. One is going to serve as holding our instance of our contract, and the other is going to hold a list of all the different accounts that are automatically generated and unlocked for us as a part of the Ganache CLI. So we'll say let lottery and let accounts. Then after that, we'll set up our before each statement that will attempt to deploy our contract and also get a list of all of our accounts. So I'll say before each. The function that we're going to pass to before each is going to have some asynchronous code inside of it. So I'll say async, and then I'll put my arrow function. Then inside of here, we're going to immediately reassign a value to the accounts variable. So I'll say accounts is await, and then we need to get a list of accounts, and we're going to use Web3 for that. So we'll say Web3. We'll access the Ethereum module and then get accounts, like so. And then just one more thing, we also need to take care of deploying an instance of our lottery contract. So we'll say lottery will be await new web3.f.contract. Remember that contract has a capital C, and then we'll pass in our interface after we parse it from JSON. So we'll say json.parse interface, and then we'll chain on our deploy statement. That's going to take in our raw compiled contract, which is the bytecode. And then we'll also send that off as a transaction to the local test network. And we need to specify the account that we're going to attempt to use for the deployment. So we'll say from the first account in that accounts array, and we'll also specify our gas as 1 million as a string. So 1, 1, 2, 3, 1, 2, 3, like so. And of course, we don't want to include the commas, so we'll take those out. Okay, so that's pretty much it. That's all of our boilerplate. Hopefully that was a good little reminder. So let's pause here and continue in the next video. Now that we've got our testing rig all set up, we get to start doing the fun part, which is to write some tests around our contract. You might be thinking, Steven, writing tests is not fun. However, trust me, this is some of the most direct experience that you're going to get around working with Web3 and contracts. When we eventually start writing web apps around these contracts, we usually only end up writing a very limited amount of logic to interact with the contract. So by writing tests, you're going to get familiar with the logic of contracts much, much more quickly. With that in mind, let's get started by writing out our first top-level describe statement. So I'll say describe, and we're going to describe our lottery contract. And then inside this thing, we'll place an arrow function, and inside there, we'll place all of our different it statements. And remember, each it statement is going to attempt to test some different aspect of our contract. I think that we'll start off with the same it statement that we started off with on the inbox contract. It's going to be an it that is going to verify that our contract was successfully deployed to the local network. So we'll start off with an it of it deploys a contract. You'll recall that last time around, we were able to make sure that the contract was deployed by asserting that the lottery.options.address property was defined. And to make sure that some value is defined, we can use the assert.ok function. So we're simply going to assert lottery.options.address. So again, this is going to be the address that our contract was deployed to on the local test network. Let's save this and run our test at the command line just to make sure that we have everything working up to this point. So at the command line, I'm going to make sure that I'm inside of my new lottery directory. So here's all my project files. We still have the same package.json file that we had previously. And you'll recall that we had added a script to that package.json file to run the Mocha test suite by running the command npm run test, like so. Just like before, it will take our compiler a moment to actually compile the tests and then run them. So we have to wait these about 4 or 5 seconds or so for the compiler to run. Okay, cool. So that looks good. It looks like our testing setup is all good to go. If you see an error message at this point, it likely means that you might have forgot to change an inbox variable name or something like that over to lottery somewhere. So I encourage you to look through your deployment script, look through the compile script and the test script, and make sure that you didn't accidentally make a reference to the inbox contract at any point. All right, now that our testing rig is definitely set up and working properly, let's continue by starting to write some more tests in the next video. Our testing setup is now ready to go. We're now going to very quickly come back to the age-old question that arises anytime we start to write tests. And that question is, what tests should we write? That's the question. That's what everyone always gets confused about. So remember, whenever you start writing tests, I really encourage you to just answer a simple question to yourself. Ask it and answer it. What behavior do you really care about with this contract? When I start looking at the lottery, I start thinking about the enter function right here. And at a very low level, well, we probably want to make sure that anytime someone calls enter, I want to really be 100% certain that their address gets added to the players array right here. I think that's really ideal. I want to make sure that if anyone calls enter and they send in the correct amount of money, which is at least 0.01 Ether, I should see their address get added. I think that's a very reasonable first test. Let's just attempt to enter into the lottery and then assert that this player's address appears in the player's array. And you will recall that we can access the player's array by using the getPlayers method that we added down here. So let's give this a shot. Back inside the test file, I'll add on my it statement, and I'll give it a description of allows one account to enter. I'm going to mark this function as being asynchronous because it's definitely going to have some async code inside of it. Inside the function itself, we will then immediately attempt to enter into the lottery. So I will say await lottery.methods.enter and .send. Now in this case, we want to make sure that we specify who is attempting to enter into the lottery, and we also need to make sure that we send along at least some minimum amount of Ether. So we'll first start off by specifying who is attempting to enter. So we'll say from accounts at 0. And then secondly, we need to make sure we send along some amount of money with this transaction. In order to send along some amount of money, we need to specify the value property. And assigned to this value property will be the amount in way that we want to send along. Whenever we specify way, we use a string and then we enter in the number of way that we want to send. Now you might be thinking that we're going to write out the amount in way in as 1 and then many, many zeros. Because remember, we need to send along at least 0.01 Ether. But rather than trying to write out 0.01 Ether as a string like so, because that's really easy to make a mistake on the number of zeros we pass in, we will instead use a little conversion method that is included with the Web3 library. This method allows us to specify some amount of Ether, so like units of Ether, and automatically have that converted to the appropriate amount of way. So we can reference web3.utils.toWay. Then we pass in the amount of Ether that we want to contribute as a string. So 0.01. And actually, you know what? We need greater than 0.01. So let's do 0.02, like so. And then we need to specify the denomination or the units for this 0.02 right here. This is supposed to be Ether, so I'm going to pass in Ether as a second argument to the two-way function. The Web3 library will take the 0.02 of Ether and then return the equivalent amount in way. So again, this entire function call right here is to just keep us from having to manually count out the 2000000, however many zeros we should have. And it's also much more legible. All right, so that's going to enter us into the lottery. Immediately after entering, we should be able to attempt to call the getPlayers method right here and get back our list of players. So this will be an array of addresses. We can then make sure that the appropriate number of addresses is present inside this array. So we can say const players is await lottery.methods.getPlayers.call. And we'll make sure we specify who is calling this function. Say from accounts at 0. Don't forget the await keyword right here, because of course this is an asynchronous method to attempt to reach out to a contract and obtain some value. So now players should be an array, and the only element inside that array should be the address of accounts at 0. So we can now write two separate assertions. One that will make sure that there's only one record inside the array, and another to make sure that the correct address is stored inside. So we can say assert.equal accounts at 0, so that's the value that it should be, and players at 0. That's the value that it actually is. We can then say assert.equal players.length. Oops. So it should be 1. That's going to be our first argument. And then comma players.length. Remember, it's always the value that it should be and then the value that it is. So that was my mistake, putting the 1 last. All right, so let's save this and run our tests again, see how we're doing. So I will npm run test. That'll start our test back up. We should now see two separate tests passing, one for deploying a contract and then one for allowing our account to enter. At present, we're not actually making any other assertion beyond this one account, and that's why I specifically specified in here one account. We can certainly come back and add in another test that then attempts to enter in two accounts. Of course, there's no issue with that whatsoever. All right, so back over at the terminal, it looks like our two tests are passing. So that's great. Let's pause here. We'll continue in the next video, and I think that we will do that additional test, something to make sure that we are able to enter with multiple accounts and make sure that each of those addresses get stored in the player's array. So let's take care of that in the next video. Our next test is going to be very similar to the one that we just wrote. The first test right here said, hey, let's just make sure that one person is able to enter. I think that our next test will assert that we are able to enter on multiple accounts, and each of those addresses will be stored inside the player's array. For the second test, we can just take this first one, so this entire it block, I'm going to highlight the entire thing and copy it, and then I'll paste it underneath the existing one. We'll take this harness right here and we're going to modify it to make sure that multiple accounts are entering. So I'm going to first start off by changing the description of the test. I'll say it allows multiple accounts to enter. And then we will add in additional enter calls. So I'll say maybe two other accounts. And I can do those other two by simply copy pasting the enter call down. We do want to make sure that we attempt to update the account that is used to enter on these additional calls. So on the second one down, I'm going to use the accounts at 1. And then on the third one down, I'll use accounts at 2. Now at the bottom, we should be able to verify by making assertion that there are 3 players inside the player's array, or 3 addresses. And we should also be able to do a little bit more copy paste here. And we'll say that accounts at 1 and 2 should be equal to players at 1 and 2, like so. All right, so let's test this out with npm run test. You might be a little bit curious, why exactly are we essentially duplicating the same test over and over right here? So we have allows one account to enter and then allows multiple accounts to enter. Well, to be honest, if one fails, it's not necessarily the case that the other one will fail as well. We could get into some crazy situation where we accidentally are only storing the latest account to enter into the lottery. So by making sure that we have a test for checking both one account and multiple, we can catch that very off chance case where we are accidentally only storing the latest entrant into the array. I know it sounds like a long shot, but hey, it's a test worth having. Remember, these contracts are storing money, and we want to make sure that we are always handling them as securely as possible. All right, let's see how our tests are doing. And yep, it looks like we're good to go. All right, so that was an easy test, essentially because we just copy pasted it. Let's continue with a little bit more complicated one in the next video. Let's continue writing some additional tests around our lottery contract. I think that the next test should make sure that a user has to send in the appropriate amount of Ether in order to enter into the contract. So if you send less than 0.01 Ether, we want to make sure that we do not allow a person to enter into the contract. This test is going to be a little bit more tricky to write because essentially we want to make sure that something goes wrong. And that's not the easiest thing to actually put together. So let's give it a shot. At the bottom of my test file, but still inside the describe block, I'll add on another it statement. For this one, we'll say that it requires a minimum amount of Ether. How about Ether to enter? Let's be really descriptive. And we'll add on async like so. All right, so this time around, we're again going to try to enter into the contract, but this time we're going to send in dramatically less Ether. So we'll say await lottery.methods.enter.send. And of course, don't forget the 2 sets of parentheses here. But this time, when we send in this transaction, of course, we're still going to say from accounts at 0. But I think that our value, the amount of Ether we send along with the transaction, will be different. So this time, let's try sending in just 200 Wei. This is going to be 200 right here. 200 Wei because we are not trying to convert it into Ether or anything like that. Now it doesn't have to be ether. I just made up, or 200 way, excuse me. I just made up that number off the top of my head. We could just as easily do, say, 10 way, or maybe 0 way. Whatever you want to do is appropriate. Our goal here is to make sure that when we attempt to enter with this, an error should be thrown. So we want to make sure that if we try to enter with an inappropriate amount of ether, something should go wrong. When we are using the async await syntax, as we are right here, for handling our asynchronous code, we can handle errors by using a try catch statement. So we're going to use a try catch, which is a part of basic JavaScript, in order to make sure that some error occurs here. I'm going to first start off by wrapping the await inside of a try, like so. All right, so notice that we have try, and then a set of curly braces. And then on the closing curly brace immediately after, we'll say catch. We'll catch an error object, and then we'll place our other set of curly braces. Now I found that a lot of people have not actually worked with try-catch statements with JavaScript before. So as a quick refresher on how they work, when we use a try-catch statement, the JavaScript interpreter will attempt to run the code inside of the curly braces of the try statement. If this code is executed without error, then everything continues along. But if something goes wrong with this line of code right here, then the catch statement will be triggered. We can use try-catch statements to automatically catch errors that are thrown by asynchronous function calls like the one we have right here. Again, in this case, we want to make sure that this call ends up in the catch. So this should throw an error. We want to see an error here. So inside the catch part, we're going to add on an assertion to make sure that we get to this point. So I will assert.ok error. We've used the OK function before. Remember, OK just checks to see and assert that some value is passed into this function. So even though this is an error object, it is a value. So we can make sure that there is an error present. Now to be triple sure, like 100% sure that this thing fails, we are also going to add a failing assertion immediately after the await. So right here, I'll say assert false, like so. And you know what? I just made a mistake. We don't want to use assert.ok here. We want just assert. When we use assert, we're going to check for truthiness, unlike OK, which checks for existence. So that was my mistake. Now you might be kind of curious why we're using assert.false right here. Well, just think about it. If the asynchronous function call right here is executed and then an error is not thrown, execution will go down to the next line of code where we will run assert false. Assert false is always going to fail our test no matter what. So if for some reason this statement does not throw an error, this line of code will run and then our test will fail. However, if this line of code right here does throw an error, then we'll end up in the catch statement where we assert that yes, something just went wrong. All right, so let's save this and give it a shot. We'll npm run test again. And while that's running, I want to mention very quickly, this is a pattern that we're going to use quite a bit whenever we want to somehow catch errors or do some error handling around any function calls that we make to a given contract. Do remember that we're only really using try catch here because we are using the async await syntax, and we capture errors with async await by using try catch. If we were using traditional promises, then we would use a catch statement instead. All right, so let's check out our tests, and it looks like everything is working. Now notice that the test is passing. It is passing because we went to the catch statement where we asserted that an error was present. And we very clearly did not run this line of code right here. So if this was ran, our test would have failed. Okay, so this looks good. We are now asserting or testing to make sure that someone has to send along an appropriate amount of ether to actually enter into the lottery. Let's continue the next section where we will start working on our next test. The last test that we wrote gave us a really good pattern for asserting that something goes wrong when we attempt to call a function. We tried to call enter, and then we asserted that either something went wrong or something went right between these two assert statements. We can now use a very similar pattern to try to test our pick-winner function. In particular, I want to make sure that if someone other than the manager attempts to call pick-winner, an error should be thrown. So if some random person calls pick-winner, we're going to run the restricted function modifier and that should kick us out of the function call. So let's give it a shot. We're going to use the exact same try catch type syntax that we used in the last test to test out the pick winner function. I'll first start off by placing our it statement, and for this one we'll give a description of something like only manager can call pick winner. Then we'll place our async keyword and open up our function. Now something to be aware of here is that we don't actually have to enter into the contract this time around. So even though normally we would say, okay, let's enter into the contract and then attempt to pick a winner, as far as the restricted modifier here goes, it has absolutely nothing to do with the number of players who have entered into a contract. So we don't have to call enter ahead of time. We can simply call pick winner and then assert that something went wrong and that calling the function threw an error. That's all. So inside the it statement, we'll place our try block. We'll say await lottery.methods.pickWinner.send. And then inside the send, so this transaction object or the transaction options that we're going to provide, we're going to specifically say that this is coming from accounts at 1. So this is not the manager right here. This is something else. Then immediately after that, we can attempt to assert false, just like we did before. Remember, assert false right here, its entire purpose is to just say if we get to this line of code, automatically fail the test no matter what. Then we'll place our catch, we'll receive the error object, and we will assert that the error exists, like so. All right, so that's pretty much it. Again, we don't have to enter into the contract before calling pick winner. We can just immediately call pick winner, and because of the way we wrote the contract, we should immediately get kicked out because of the restricted modifier. So let's give this a test at our terminal. I'll run npm run test, just as we have several times before, and we'll wait a couple seconds for the compilation process. Now, one thing I want to throw out there regarding this test that we've written is that if you have worked with the assert module from Node before, you might be aware that the assert module has a helper for catching functions that throw an error. We're not using that here because the async await syntax does not work nicely with that built-in helper on the assert module. Now, that might sound like a mystery to you. I just mention it if you are aware of the function throw helper that is included in the assert module. I just want to throw it out there. All right, so back over at a terminal, it looks like that test is passing. Cool, so let's continue with one or two more tests in the next video. I think there's just one last test that we need to write. I think we need to write a test that runs through our contract from start to finish. So something that attempts to enter a player into the contract and then attempts to pick a winner, and we should verify that the winner receives some amount of money, and we should also verify that the player's array gets completely reset and emptied out. So we're going to write that test inside this video. Let's give it a shot. Back inside of our test file, at the very bottom, we'll add on a new it block. So we'll say that this one has a description of it sends money to the winner and resets the player's array. Don't forget to add on the async keyword over here for our arrow function, like so. All right, and then inside of here, we can start writing the actual test. Before we do, I want to talk about the strategy for this test just a little bit, because this one is going to be a little bit more complicated to write than some of the other tests that we've done so far. The first thing I want to remind you about is that the pick winner function is random in nature. So if we enter in, say, 3, 4, or 5 players into our contract and then call pick winner, we would have to write a lot of code inside of our test to look at the account balance of those 3, 4, or 5 players and figure out exactly which one won the lottery. So rather than writing all that logic, we can take a little bit of a shortcut. We're going to instead only enter in one player to the contract. So we'll always know that that one player will be the winner when we call pick winner. Of course, yes, this kind of doesn't test out the random nature of the contract that well, but it's going to make writing the contract or writing the test much more easy and straightforward. So we're going to only enter in one single player so we don't have to deal with the random nature of who actually wins. All right, so let's give this a shot. Back inside of our it block, we'll first start off by entering in one player to our contract. So we'll say await lottery methods enter.send, and we will enter in, how about accounts at 0. So this is the person who's going to enter into the contract. And we're going to send in some minimum amount of Ether. This is the amount of money that they are essentially wagering on the lottery, as we've spoken about several times before. Remember that the value right here needs to be in terms of way. So we're going to use that two-way helper again that is a part of the Web3 library. So we'll say Web3 utils two-way. And this time around, rather than sending in 0.02 Ether, let's make our lives a little bit easier. We're just going to send in 2 Ether, period. So 2 Ether, like so. So this is going to be a little bit easier for us because now we don't have to worry about that like 0.02 that we were dealing with earlier up here. Just send in 2 and that's good enough. And of course, this could just as easily be, say, 1 Ether, really whatever we want it to be. Now we have to figure out some way of figuring out exactly who is going to win the contract, or exactly how we're going to figure out the accounts at 0 wins when we call the pick winner function. So I'm thinking that one possible way to approach this would be to retrieve the account balance, or the amount of Ether that accounts at 0 controls, both before and after calling the pick winner function. Because that accounts at 0 just sent in 2 Ether to the contract. And when we call pick winner, they should essentially just receive that 2 Ether right back. So if we get the amount of Ether that accounts at 0 controls both before and after calling pick winner, we should see that those two balances are different by 2 Ether, almost exactly 2 Ether. And I say almost for something that we'll talk about in just a second here. So back inside of our it statement, we will get the initial balance of accounts at 0, or the amount of Ether that this account controls. To do so, we'll say const initial balance, balance is await, and then to get the balance of an account, or the amount of Ether that it controls, we can call web3.f.getBalance. This is a function that will return the amount of Ether in units of way that a given account controls. This function can be used with either accounts that are owned by people like you and me, which we refer to as external accounts. It can be also used to retrieve the balance of contract accounts as well. So essentially, you throw any address you want into this function, and that will return the amount of Ether that is assigned to that address. In this case, we want to get the amount of Ether that is controlled by accounts at 0. So we'll pass that address in, like so. Now we can attempt to pick a winner inside of our contract. Once we pick the winner, accounts at 0 should basically just receive back the 2 Ether that they sent in. So we will pick the winner by writing lottery methods pick winner dot send from accounts at 0, like so. One thing that I want to remind you about at this point is to make sure that you've got the await keyword on all 3 lines that we've written out so far. So these are all asynchronous requests that we are making to the local Ethereum network. So you need to make sure you're using the await keyword on all these. Really easy typo, easy little word to leave out. All right, so now that we're calling pick winner, accounts at 0 should essentially be receiving back the 2 Ether that they just sent in. So we sent in the 2 Ether, we're now 2 Ether less, or we have 2 Ether less right here at this point for our initial balance. And when we call pick winner, we receive that money back. So we can now get our final balance, which will be again await web3 f get balance for accounts at 0. And now we can compare the difference between initial balance and final balance. Now you might be thinking that the difference between these two balances right here is going to be exactly 2 Ether. However, unfortunately for you and me, it is not. So recall that anytime we send a transaction into the network, we have to pay some amount of money in gas to get that transaction to be processed by the network. So the difference between final balance and initial balance is going to be 2 Ether. However, we also just spent some amount of money on gas. So in reality, it's going to be slightly less than 2 Ether. The difference between initial balance and final balance right here will be slightly less than 2 Ether. Now it's going to be really challenging for us to compute the amount of Ether that we just spent on gas. So rather than trying to factor in the exact amount of Ether we spent on gas, we can say that, well, final balance and initial balance should be basically have a difference of slightly less than 2 Ether. So let me show you the code we're going to write to compare the difference between these two things right here, and I think it'll make a little bit of sense. So we'll say const difference is going to be final balance minus initial balance, and then we will assert that the difference here is greater than web3.utils.2way, and we'll do, say, 1.8 Ether. All right, so we're taking the difference between the two, and then we are making sure that that difference is greater than 1.8 Ether. So why did I pick 1.8 right here? Like, what's the significance of 1.8? Well, basically the 1.8 is just allowing for some amount of gas cost. That's what this 1.8 is doing right here. It's saying we acknowledge that the difference between these two things will be around 2 Ether, but it'll be slightly less because we just spent some amount of money on gas. We don't know how much was spent on gas, and we don't really care that much. We just want to make sure that the difference here is somewhere in the realm of close to 2, but slightly less than 2. Now, if you really want to see how much we spent on gas, you can always do a console log of final balance minus initial balance, or essentially the difference, which we have right here on this variable. And the difference between these two will be around 2 Ether. And then whatever amount different it is from 2 Ether, or however much offset it is from 2 Ether, will be the amount of money that we spent on gas. Okay, so let's now save this file and try running these tests. So back at the terminal, we'll do npm run test. And of course, wait for the compilation process, which I know we all love to wait for. All right, so there's our tests, and here we go. So here's the difference right here between the initial balance and the final balance. So essentially it's 1.99 Ether. And it's not exactly 2 Ether because we spent a tiny bit of money on gas. So that's why we did the 1.88. Now, if we wanted to, we could certainly update this amount right here from 1.8 to something like, 1.9 or something like that and be a little bit more precise. But honestly, 1.8 is pretty much good enough to verify that, yeah, we received some amount of money back when we called the pickwinner function. All right, now the last thing I'm going to do is to clean up that console log because we don't really need it inside of here. And then just for stylistic purposes, I'm also going to remove the new lines to just put all those lines of code right next to each other. I think that makes it a little bit more legible. Okay, so I think that's basically it for testing of this contract. Now, if you want to, you could add in one more assertion to this test right here. I think that it would be valuable to assert that the players array gets emptied out after calling pick winner. So if you want to, you could always retrieve the list of players from the contract and assert that it's empty and say, okay, look, contract is totally reset and we're ready to go for the next round. And maybe another assertion you could make would be to assert that the lottery itself has a balance of 0. So in other words, assert that all the money that got entered into this first round of the lottery got sent out when we called the pick winner function. So those are two assertions that you could probably make to make this test a little bit more robust. And I'll leave it up to you to add those in if you want to. All right, so I think that our tests here are looking pretty great. Let's take a break and continue in the next video.